Hi, welcome to the 2008 AP Calculus BC number 5 FRQ. So this problem has three parts. Part A starts with the function f has a critical point at x equals 3. At this point, does f have a relative min, a relative maximum, or neither? Justify your answer. So what you want to do is find if the sign changes at x equals 3, and then if the sign does change, what does that signify? So what you have here is f prime of x equals x minus 3 times e to the x equals 0 at x equals 3. So what I did is set up this table here where you have your ranges here, your domains 0 to 3 and then greater than 3. And what you're going to do is pick some test values. Obviously, one's going to be less than 3, one's going to be greater than 3. What you do then is you plug these values back into the derivative to see what you get. And what you're really looking for is not the actual quantity of the value, but just the sign. So this is why I have the conclusion here where I get it's negative when the test value is 2, and it's positive when the test value is 4. So what this shows is that if this was a quadratic, you'd have something like this, a little parabola like this, where the slope is negative on this side and then positive on this side, showing that this would be a relative minimum. So in your justification, what you're going to want to write is something like this. There is a relative minimum at x equals 3 because f prime of x is less than 0, showing that it's negative, on 0 x3, and f prime of x is greater than 0 when x is greater than 3. This gives a very clear explanation of what you're trying to show and will get you the full points. So in this problem, you would get 2 points for this. So what you do, you get a point for showing that there is a minimum at x equals 3, and then 1 point for the justification. So in part B, it asks, on what intervals, if any, is the graph of f both decreasing and concave up? Explain your reasoning. So as soon as you see concave up or down, you'll want to find the second derivative. Luckily, we already have the first derivative, so that really is only one operation. So what you do is you do a quick little chain rule on the first derivative, and you get that the second derivative is e to the x plus x minus 3 times e to the x. You can simplify this to x minus 2 times e to the x. So what you see very quickly is that there's going to be a point of inflection at x equals 2, because that's when the second derivative would be equal to 0. So this is where you're going to want to be able to see whether it's concave up or concave down on the different intervals. So you can set up another table just like part A. Choose your test values. I chose 1 and 3 because they're on opposite sides of 2. And you end up seeing that from 0 to 2, f double prime is negative, and then when it's greater than 2, f double prime is positive. So this shows that it is concave up. F of x is concave up on x is greater than 2. You have to be very careful about that. You can't just say it. That's a very tricky thing. You have to signify exactly what you're thinking. You don't actually have to write this justification I just did to explain it in the video. So now you know it's concave up on x is greater than 2. You got to find when it's decreasing. If you remember from part A, the derivative is negative when x is between 0 and 3. So what you're going to want to do is find an intersection. So I did something here where I drew this little graphical idea. So I didn't actually graph the function because we don't know the original function yet, but I kind of just showed where the different breaks in the values of the first and second derivative would be. So I have this line here showing that it would be concave up from here over and concave down from here over. I also have this line right here showing that the first derivative is negative to the left and positive to the right. So what you're going to want to do is find the intersection, which ends up being right in here. So your intersection is from 2 to 3, and so your conclusion can be, therefore, f of x is concave up and decreasing on 2 to 3. And that's all you need for that problem. And what you get is 3 points. You get 2 for showing the derivative. So you really want to do something well there. And then your answer with the reason comes here. All right, let's move on to part C. So Part C just says, find the value of f of 3. So a very quick thing you're going to want to think of is the fundamental theorem of calculus, which shows that f of b minus f of a equals integral from b to a of f prime of x dx. And since you already have f prime of x in this case, and you know the limits, you can very easily use fundamental theorem of calculus. So I set up one here. F of 3 minus f of 1 equals integral from 3 to 1 f prime of x dx. This ends up as 7 plus integral from 1 to 3 of x minus 3 e to x dx. So you see this integral here, and it's a very tricky one. Luckily, we're in BC, so we have a trick for this partial, or integration by parts, excuse me. So what you're going to want to do is set u as x minus 3, set dv as e to the x dx. Remember, you're setting dv, not v. You end up with v as e to the x, it's a very simple integral, and then du is just dx. So you can move that down, so you end up with f of 3 equals 7 plus x minus 3 times e to the x from 3 to 1, evaluated from 3 to 1, minus the integral from 3 to 1 of e to x dx. You can keep carrying that out, as that's a very simple integral as well. You plug in the values, and you end up with your final answer as 7 plus 3e minus e to the 3. So that's basically how you do that problem. It's a pretty simple integral. You get 4 points for this last part by having the initial condition here, which was using f of 1 and plugging in the 7 for it. You get 2 points for this integration by parts, and then you get 1 point for the final answer. That ends up with your total of 9, and that's how you get a perfect score on this question. It's a pretty straightforward question, and I really think that it's something that when you see on the AP test, it's something you should be able to identify very quickly and be able to get some very quick free points out of this problem. I hope this helped. Thank you.